Reality's missing piece. Take a look at your hand. It feels solid. It moves through 3 dimensions of space. It seems undeniably, fundamentally real. But what if that feeling of solidity, that perception of depth, is the most profound illusion ever conceived? What if the universe has committed a grand act of larceny, stealing a fundamental truth about its own nature right from under our noses, leaving us to navigate a ghost, a projection, a hologram? This isn't a thought experiment pulled from a science fiction novel. This is a possibility that bleeds from the cutting edge of theoretical physics, a mind-bending concept that suggests our entire 3-dimensional existence is nothing more than a complex image projected from a flat 2-dimensional surface. The crime scene is the cosmos itself, and the stolen item is a dimension. Not an extra one we can travel to, but a foundational one that has been hidden from our perception. The culprit? The laws of physics themselves. This is the essence of the holographic principle, an idea so audacious it forces us to question the very floor beneath our feet. To grasp this, we first need to confront the nature of a hologram. We've all seen them, those shimmering images on credit cards or novelty posters. A simple laser hologram being created. It works by recording an interference pattern on a 2-dimensional film. This pattern doesn't look anything like the final object. It's a chaotic-looking scramble of light and dark fringes. But when you shine the right kind of light on that 2D plate, a full 3-dimensional image springs into existence. The key takeaway is this: all the information required to describe a 3D object is fully encoded on a 2D surface. The depth, the parallax, the feeling of volume, it's all an emergent property, a trick of light and information. Now, let's scale that idea up to the size of the entire universe. The holographic principle proposes that our universe operates in exactly the same way. The 3 spatial dimensions we experience, along with the dimension of time, could be a grand projection. The real universe, the fundamental substrate of existence, would be a flatter, lower-dimensional reality located at the cosmic horizon, the edge of the observable universe. Everything that has ever happened, is happening, and will happen within our cosmic volume, the birth of a star, the formation of a galaxy, the intricate dance of atoms that make up your body and your thoughts, could be nothing more than information written on this distant, 2-dimensional boundary. This is the Grand Larceny. We think we live in a vast, voluminous theater, but we might just be characters projected onto a screen. The dimension we're missing isn't a 4th or 5th spatial one. It's the realization that one of our perceived dimensions is an illusion, a clever reconstruction built from a lower dimensional blueprint. This fundamentally changes what we mean by space and reality. We tend to think of the universe as being made of tiny particles, quarks, electrons, photons, swimming in the empty container of space-time. But the holographic principle suggests the universe is made of something far more fundamental: information, bits. The smallest possible unit of information, a yes or a no, a 0 or a 1. In this view, particles, forces, space, and even time itself are not the fundamental ingredients. They are emergent phenomena, the result of how these fundamental bits of information are processed and arranged on that cosmic boundary. Think of it like a video game. On your screen, you see a character running through a lush 3D forest. But at the most fundamental level, on the computer's processor and in its memory, it's all just a stream of binary code, ones and zeros. The 3D forest is a sophisticated reconstruction, an emergent reality born from a simpler underlying code. The holographic principle suggests our universe works the same way. We are living inside the video game, perceiving the 3D forest as our total reality, completely unaware of the fundamental code running the show on a distant, lower-dimensional hard drive. This isn't just philosophical navel-gazing. This radical idea emerged from the most extreme environments physicists can imagine, places where our two greatest theories, general relativity and quantum mechanics, are forced into a violent confrontation. It grew from a deep puzzle about the nature of black holes, objects so dense they warp the fabric of reality itself. These cosmic behemoths turned out to be the perfect laboratory for testing the limits of physical law, and in doing so, they provided the first tantalizing clue that our perception of dimensionality was deeply, profoundly flawed. The evidence they held hinted that information couldn't be contained within a volume in the way we always assumed. Instead, it seemed to be plastered on a surface, just like in a hologram. This shocking discovery was the first thread that, when pulled, threatened to unravel our entire conception of the cosmos, suggesting that the universe is far stranger and far more elegant than we ever dared to believe. It sounds like madness, but the universe has left behind fingerprints, and the first place to look for them is at the edge of infinity, in the crushing darkness of a black hole. Hologram evidence explained. The leap from a philosophical concept to a scientific theory requires evidence, and the first piece of hard mathematical evidence for the holographic principle came from the universe's most mysterious objects, black holes. For decades, black holes presented a terrifying paradox. According to Einstein's theory of general relativity, anything that falls past a black hole's event horizon, its point of no return, is lost forever. But a core principle of quantum mechanics is that information can never be truly destroyed. It can be scrambled, rearranged, or hidden, but the underlying data that describes a physical system must always be conserved. So, what happens when you throw a book with all its intricate information into a black hole? Does the black hole simply delete that information from the universe? This was the information paradox, a deep conflict between our two pillars of modern physics. The breakthrough came from the work of Jacob Bekenstein and Stephen Hawking. They began to explore the thermodynamics of black holes, treating them not just as gravitational monsters, but as physical objects with properties like temperature and entropy. Entropy is a crucial concept here. It's often described as a measure of disorder, but in physics, it's more precisely a measure of the total amount of information required to describe a system. A perfectly ordered crystal has low entropy. A chaotic gas of particles has high entropy. Bekenstein and Hawking made a stunning discovery. They found that the entropy of a black hole, the total information it contains, was not proportional to its volume, as one would intuitively expect. Instead, the black hole's information content was proportional to the surface area of its event horizon. This result was revolutionary. Imagine a library. You would expect its information capacity to be determined by its volume, how many shelves and books you can fit inside. But the black hole was like a library where all the information of every book was somehow tattooed onto the exterior walls. Nothing was actually stored inside. This was the first concrete physical example of the holographic principle in action. A three-dimensional object's properties were being fully described by a two-dimensional surface. It suggested a fundamental limit to the information density of the universe, known as the Bekenstein bound. You can't just keep cramming information into a region of space indefinitely. At a certain point, it will become so dense that it collapses into a black hole, and the maximum amount of information you can then store is dictated by the surface area of that hole. This implies that information, the fundamental stuff of reality, might be two-dimensional in nature. While the black hole evidence was a powerful clue, it was a specialized case. The idea was catapulted into the mainstream of theoretical physics in 1997 by physicist Juan Maldacena. Working within the framework of string theory, he uncovered something astonishing, a precise mathematical duality or dictionary that perfectly translates between two wildly different-looking theories. This is known as the ADS-CFT correspondence. On one side of this duality, you have a theory describing gravity and strings in a specific type of five-dimensional, negatively curved spacetime called anti-de Sitter space. This is the bulk universe, analogous to our 3D world. On the other side, you have a quantum field theory without gravity, similar to the one describing particle physics, living on the four-dimensional boundary of that space. Maldacena proved that these two theories were mathematically equivalent. They are two different descriptions of the exact same physical reality. Anything that happens in the five-dimensional universe with gravity has a corresponding, calculable description in the four-dimensional universe without gravity on the boundary, and vice versa. It's like having a book written in English and a perfect, flawless translation of it in French. They use different symbols and grammar, but they contain the exact same information and tell the exact same story. This correspondence provided a concrete working model of the holographic principle. It showed, in the rigorous language of mathematics, how a reality with gravity could emerge from a lower-dimensional, gravity-free system of quantum interactions. The complex dance of gravity in the 3D bulk was a holographic projection of simpler particle physics on the 2D boundary. So, where does this leave us? We have a clue from the real world in black holes, suggesting information lives on surfaces. And we have a perfect mathematical model from string theory, showing how a higher dimensional world with gravity can be a projection from a lower dimensional one without it. While the ADS-CFT correspondence describes a simplified toy universe, not our exact one, many physicists believe the underlying principle holds true. Our reality, in all its perceived three-dimensional glory, could be an elaborate hologram projected from information encoded on a distant two-dimensional surface. We are not the solid beings we think we are. We are emergent patterns, intricate data sets written on a cosmic screen. The Great Larceny wasn't a theft, but a misdirection of cosmic proportions, hiding the true, flatter nature of reality in plain sight. If this is true, then the ultimate question is no longer just what is the universe, but what is the projector? And if you are a hologram, what's the first thing you try to glitch?